In this video, we are going to look at some examples on how to find the remaining factors of a polynomial when given one of the original ones. So all we want to do is find the remaining factors. We're told this binomial x plus 5 is a factor. So we already know one of the factors of this polynomial x cubed plus 6x squared minus x minus 30. We want to find the remaining ones. To do this, the first thing you want to do is you want to kind of divide this binomial out. So you do synthetic division. And so the solution to x plus 5 is negative 5. So I set up synthetic division with negative 5. We have the coefficients of 1, 6, negative 1, and negative 30. There's no gaps in the exponents. So 1, 6, negative 1, negative 30. Let's set up our remainder box. And we're told x plus 5 is a factor. That means our remainder should be 0. If it's not 0, when you're told it's a factor, that means you did something wrong. So let's just check our synthetic division. Drop down the first term. 1 and negative 5 is negative 5. Add vertically. 6 and negative 5 is 1. Negative 5 times 1 is negative 5. Add vertically, you get negative 6. Negative 5 and negative 6 is positive 30. And negative 30 plus 30 is 0. So I am correct. There's nothing wrong with my synthetic division because I'm told x plus 5 is a factor, which means that my remainder should equal 0, and it does. Next, you take a look at the polynomial that remains after you do the synthetic division, and that would be x squared plus x minus 6. So you look at the polynomial that remains and you factor it down. So if I have x squared plus x minus 6, this is factoring a trinomial with a leading coefficient of 1. So I can set up my two factors. The first place is going to be x, and you want numbers that multiply to give you negative 6, and they add to give you positive 1. And so since they have a negative 6 product, a positive 1 sum, that'd be a 3 and a negative 2. So x plus 3, x minus 2. Those are the remaining factors after you do synthetic division. So that's the process we're going to use in these examples. We're told our binomial is a factor. So that tells us the remainder should be 0 when we do synthetic division. After we do synthetic division, we're going to take that polynomial that remains and factor it. So let's look at example 2. Given the polynomial and the binomial as one of the factors, find the remaining factors. So we set up, again, first thing, we set up synthetic division. So we have a binomial of x minus 6, so our solution is 6. So that's what we're going to do synthetic division with. Our exponents are in decreasing order with no gaps, so coefficients are 1, negative 11, positive 36. So I'm just going to put 36. And then negative 36. Set it up with the remainder box. And let's do the synthetic division. We drop down the first term of 1. 6 times 1 is 6. Add vertically, you get negative 5. Take 6 times negative 5 and you get negative 30. Add 36 and negative 30, you get positive 6. 6 times 6 is 36. Add vertically and we get 0, and we should get 0 because we are told x minus 6 is a factor. So we want to make sure when we're told we have a factor, our remainder should equal 0, and it does. Now you take a look at what the polynomial is that remains, which is x squared minus 5x plus 6. and you factor that polynomial. So we're going to factor the remaining polynomial. Trinomial, leading coefficient of 1. So that means our product is 6. Our sum is -5. So you want two factors of 6 that add up to -5. We have x and x. That would be a positive product with a negative sum, so they're both negative. So I would say x -3 and x -2. -3 times -2 is +6. -3 plus -2 is -5. And so my remaining factors are x -3, x -2. So in these two examples, we looked at how to do synthetic division with a binomial. We set it up, we're told we have our binomial that is a factor, so we should get a remainder of 0. You take the remaining polynomial, write it out, and factor it from there to get the remaining factors. There are a couple other examples in the next video, so please continue on.